First though, this, then I'll get to the one that my student was asking about. This was not too bad. I brought it in for a reason. It says negative 2, parenthesis n plus 3 is less than 8. That's an inequality. Solve it much like an equation. Distributive property, no problem. That is no problem. If I treat this like I would an equation, no problem. Add 6. And quickly write it as this. 8 plus 6, you're done. If I still treat it like I would an equation, divide by negative 2. These cancel. Got n now. My students in the 4 o'clock session earlier today, we did one like this, right? The same problem. They recognized this. Oh, I remember what happens, Professor. If you divide or multiply by a negative, what happens? The inequality symbol reverses. That's why I brought this in. So this now becomes n is not less than, changes to a greater than, and of course the other side is a negative 7, and there's the answer. Now, one of my students came and said, Professor, I noticed you did a little visual to show what that means, but can I just jump directly into and show you in interval notation what that means? Yes, it means we're going to start out with negative 7, not including, and go through infinity. And there's your answer. Done. No problem. Part B. Now, this is the one I think the student came up to me and asked about. It looked like this. 4 is less than or equal to 2x plus 2 is less than 10. Now guys, before going further, I'm blessed to have these two TAs. Isujin, what she does for us, she'll take these notes for you guys. Of course, you're going to be taking notes, right? She also takes the notes. And she puts it in nice form for you. She condenses it down, and she says, we'll send those out to you. Okay, and Mr. Park has just agreed that he's going to work out that worksheet, or have the answers for that worksheet, and send out the answers to that worksheet that we have. So he's going to send the answers out to that worksheet. She's taking notes along with you guys taking notes, and she's going to send out a condensed version of the notes here. Guys, this one is a combined inequality. Now, when I say combined, there's 2 in 1. He was asking me at the break, he says, Professor, could I do it like this? Could I separate and show you that one of the inequalities looks like that? In other words, 4 is less than or equal to 2x plus 2. No problem. And then, could I show that in that combined form, Professor, there's another one? I'll put the word here, and. The other one looks like this. Right, that's 2x plus 2 is less than 10. We step back and make sure I have everything copied down correctly. You guys agree? Is that it separated? And you could solve each one as he was doing. He says, Professor, I can solve each one now. You separate them for me. It's combined. Guys, I'm going to solve this one right quick if you don't mind. I'm going to move that 2 over by subtracting. And of course, we get 2. Less than or equal to 2x. Since I'm trying to solve for x, divide both sides by 2. Thank goodness that is a positive 2. They cancel here. No reversing of the symbol. 1 is less than or equal to x. And that's the solution to the first one. Don't make a mistake. Do it fairly quickly. Down here in the red, I need to solve that one that I separated from the combination. Let's subtract 2, make this 2x is less than 8. Let's move the 2 over. Divide by 2, x is less than 4, no reversal. And there's the other one. Now, does anyone see any way that we could deal with this? It looks a little awkward. This one says x is less than 4. You said, Professor, I don't know what that means. This one might look a little better. It's true right now. It may look a little better if you rewrote it in this order, just to make a little bit more sense. See if you guys agree. 1 is less than or equal to x. Is that the same as saying this? Just turn it around. I think it looks better turned around like that. I didn't change the answer, I just turned it around. I think it looks better expressed like that, which is the same as this. So guys, I got to show now this along with this as my answer and put in interval notation. Now I think this one I will do by visual and then write in interval notation. So guys, on the side here, this one says x is greater than or equal to 1. We all know where 1 is. That's going to be closed in and shaded to the right. I want to do my shading like this. And bear with me. Of course, that goes forever. That's a visual of this. Now let's put the red one on there. The red one says now x is less than 4. I know where 4 is. It's up here. Less than, not less than or equal to, so it's open. And to show less than 4, you're shading in this direction, to the left, forever. Guess what they want for an answer? If you did this much to it. Wonder what they want for the answer. I graphed this one by itself, and I graphed this one on the same number line. What do you think they're looking for? What are we looking for a final answer? Where do they overlap? Where do they intersect the black and the red? This one was moving in this direction, the black, and the red one was moving in this direction, to the left of 4. Where do they overlap or intersect? And that's the answer for both. I see a hand going up. Yes?
1, 2, and 3.
Okay, give me all the numbers, not just 1, 2, and 3. I agree there. There's many more numbers. Give me a nice way to express in interval notation where the red and the black overlap or intersect. And please tell me, guys, I'm right on top of the board, is it right in here? Is that where they overlap? Now, can someone tell me what does that look like in interval notation? I see a hand going up. Yes?
Bracket 1 and then 4 with the parentheses.
Thank you. That's it right there. That's it right there. Done. Now, that's what my student was showing me. Sometimes we luck out. If I go back to the original combined, watch carefully, inequality, it looks like this. I'm going to do it this way this time. We get the same answer. Why not, Professor? Just jump into it, leave it combined. Don't separate like you did. Just leave it combined and do this. Subtract 2 from all 3 parts, which is valid. Make this 2 less or equal to, these drop out, 2x less than 8. And then do what then to get the x completely by itself? Divide everything by 2. Thank goodness that's a positive. And of course, it's going to be a 1 here on the left, less or equal to, these cancel, which I want, x is less than 4. Please tell me, is this and this in interval notation, is it saying the same thing? Is it saying x is caught between 1 and 4, where the 1 can be included, bracket, 4 cannot be included? Are these saying the same thing? So I let mine combine, he separated them, and we got the same answer. You may end up with a combined inequality. Part C, and sort of get ready to close this down here shortly. Here we go. Watch carefully. This. Watch carefully. That's a quadratic. Not equation. Inequality. Now, if they still be using some of those strategies you saw before the break, does anyone have an idea of that quadratic staring at me is x squared subtract 3x subtract 10? Does it factor? If it does, it would save you a lot of time. Or I could go on the side and use quadratic formula. Or I could try that new technique, completion of the square. But I think, does it factor? If it does, that would really help me. I think it's going to factor into, guys, what is that, x subtract 5 times x plus 2, check my work out here, less than 0. Yes or no? Now I say, Professor, if it were before the break, I know what to do, Professor. You did this. You split these up, and you set each one equal to 0. The technique we use. And before the break, we'd have this. And you place them in those little braces, and you said that was the answer, and we left it before the break. Well, this is not an equation, though. This is an inequality, so I'm not quite finished. There's more to it than what you saw before the break. What else may I do here? I've got to take these two definitely and work with them, and I'm going to go to a number line, because those are going to be some shading intervals. We'll place -2 here, 5 here. The way it's written, I don't see an equals mark here, so both these are not to be included, they're open. If you don't see an equals mark, those two numbers that you would have gotten before the break are not included. Now you say, Professor, since it's not the same as before the break, undoubtedly you're going to shade somewhere. You may shade off to infinity, shade on this side, you may shade on the left, you may shade in between, who knows? I know you shade the last one in between. You may shade this in between, say that's the answer. Then we'll put it in interval notation. So guys have choices. Am I going to shade starting here and go to the left forever? Now this is negative infinity. So we're going to talk about infinity. Or will I shade just in between -2 and 5 and write something like I did this one? Or am I going to write 5 through infinity if it goes this way forever? Which of those three choices is it? We really don't know yet. Does anyone have an idea before I show you a little technique to test to make sure you get the correct intervals? Yes?
I think you do two, like answers, so it's like bracket, or sorry, not bracket, what is it, parentheses, 2.
Okay, just tell me which of the three intervals, because I'm going to shade here with a different color. I read it. And we're going to shade out here and say, Professor, that's the answer. Then we'll put it in interval notation later. Am I going to shade in between, Professor? Maybe. Or am I going to shade to the right of 5? I'm going to decide. Or am I not going to shade at all and say this thing makes no sense? It's no solution. Does anyone have an idea of where I'm going to shade? Okay, here's the best way to find out. You're going to choose a number of your choice in each one of these so-called sections or intervals. So guys, out to the left of -2, you guys show me a number out there, your choice. Could be a -100. Could be a -1,000. I'm going to stick with maybe a -5. But some number to the left of -2, you get to choose that. I'm going to show you what you're going to do with it later. In between, you get to choose some number in between -2 and 3. Well, there's an infinite number of numbers between -2 and 3. I just need one. I'm going to try myself 0. I think 0 would be easy to work with, and 0 does fall in between those two. You may try 1, or -1, or maybe 2.75. You got to try something. Out to the right of 5, you could try 1,000 if you wish. I'm going to try 8. So I tried a number of my choice in each one of those intervals. Now what am I going to do? I'm going to test. And watch what carefully I will do here. I'm going to go back to the red. There it goes, guys. I'm going to replace x by my choice out here is -5. I'm going to put a -5 in for the x's here. A -5 subtract 5 is going to be a -10 altogether. All I'm concerned about is just what sign is it. It's negative. It's a -10. So place a negative sign right here to show that's negative. I'm also going to put the -5 here. -5 plus 2 is a -3. That's another negative. I just want the sign. So both these come out to be a negative when x was replaced by a -5. Now what does a negative times a negative in algebra gives you? It gives you a positive. Look in the red. What was I looking at? It says you're looking for something that's less than 0. What does less than 0 imply? Negative. You're looking for a result that's negative. I didn't get that result. So that means that side is not to be shaded. That's not part of the answer. Maybe it's in between. I've tested some of these where nothing works. Let's try in between. In between, I'm trying 0. In between these two. Let's go back and put a 0 in. 0 subtract 5. I know it's a -5. It's negative. 0 plus 2, that's a positive 2, positive. I'm just looking at the signs. A negative times a positive? Negative. Now, does that satisfy this? Yes, that says you have finally discovered just this one check. Tells me all those will work. In between. I'm going to test out to the right. I doubt if it works, but I'm going to test it. I chose 8. Let's put an 8 in. 8 subtract 5, I know it's a positive 3. 8 plus 2, that's a positive 10. And a positive times a positive gives me altogether what? Positive, which does not satisfy what I'm looking for. So I can't use it. So after all that testing and so forth and so on, I have my answer. And the answer in integral notation, it would be expressed as, I'll put it right here, guys, open, -2, up to 5, open. And there's your answer to this. Leave it out. Now you get outside that interval, and that original inequality will not work. Yes?
Is there a pattern where the intervals always go positive, negative, positive?
Not always.
Okay.
I'd go ahead and check for sure.
Okay.
Not always. Well, you guys know, these are a little different. They're called quadratic inequalities. A little bit more work required. Okay, that one's done. Letter D. So we're going to throw a name here. What I'm using here when I look at these signs, calculus likes to call this, you are using something called sign analysis. You look at the signs and each one of those intervals and decide which will work. It's called sign analysis. Now, letter D, I brought something else in here to sort of help me close this down pretty soon. Oh, it looks like this. X squared, x cubed. Is greater than 4x. Why not? You step back and look at it. Okay. Now this is not a quadratic. It's a cubic. But still they want you to solve it. An inequality. Can anyone give me a suggestion on what would you do first? Just to get a little partial credit, what would you do first? In your attempt to solve this. Go for it. Yes?
Move the 4x to the...
Let's get that one side to be 0, which is critical. Move the 4x over, and you got that. Now the one I just finished up here, this factored. Will this one factor? If not, I've got to do something with it. Will it factor? I hope it does it? Can I take out a common factor of maybe what? X first? And if I take out x, guys, well, I have x squared subtract 4 remaining at this point. It looks like that. Yes or no? Oh, this is going to be an interesting one. Does it factor further? I think the x squared subtract 4, they call it difference of squares. It will factor further into x subtract 2, x plus 2. Wow. Now I'm ready to go to the number line like I did on this one. Place my numbers, and then I'll give my choice or my test numbers. I'll have to come up with some test numbers, and we'll test it. See what works. Guys, on the number line, anyone tell me, based on what you see right to the left in red here, what are my numbers that you're going to place on the number line, and then we'll give some other numbers to test. Go for it.
0, -2, 2.
I got to see 0, -2, and 2. Beautiful. Beautiful. But all he did for the class was to split these up. He says, Professor, if I take the time and I'm patient and I do this business, I will get those numbers. Now, should those numbers be closed in to show they are to be included in the final answer, or should they be open, or should maybe one be closed in, the other one open? What's going on? They're all open. Again, like that last one. Now here goes. Where should I shade? I've got 4 regions, 4 intervals. I may shade out here, who knows? I haven't tried this yet. I may shade here, who knows? Shade here, shade here. Guys, out to the left of -2, it's entirely up to you. I'm gonna try -6. In between, entirely up to you. I'm gonna try -1. Here, I'm try a +1 in that interval. And finally, out to the right, I think we'll try 10. Now, all those are your choices. In this case, my choices. And what I'm going to do with them, I'm going to take them right here and look at the signs. By the way, I'm looking for the sign, the final result to be what type of a result? Positive. If I don't get a positive, I can't shade there. First test number, -6. Here goes, guys. Replace x by -6. Of course, it's negative. Put a -6 here. -6 subtract 2, that's a -8. I'm just looking at the signs. -6 plus 2, that's -4, another negative. And I know and you know, a negative times a negative times a negative will give me a negative. Did it give me a positive? I'm looking for a positive. So did this work? Is this positive? No, so I cannot, after all that work, I can't shade in. So that's not part of the answer. The sad thing would be, we test all these intervals, nothing works. I hope something works. Let's try this one. -1, here goes. Replace x by -1, guys. I'm running out of space here. If you don't mind, I'm gonna erase this. Test it there. Okay, in between, I've got a -1. I'm sorry about the sign. -1 subtract 2, that's a -3, another negative. A -1 plus 2, that's a +1. Let me step back and see if you guys agree. I'm on top of the board here. Are those the signs? A negative, a positive. All together, what is that?
Positive.
Positive, which I want. That says you're looking for a positive, greater than 0. So you have finally discovered something that works. Get the shade. Right next to it, who knows, it may work. I'm trying 1. Let's put a 1 in there. Replace x by 1. Again, I'm running out of space here, guys. That's a positive. 1 subtract 2, that's a -1, negative. 1 plus 2, of course, is a +3. All together, please tell me, is that another negative?
Yes.
Can't use it. Not in this problem. Out to the right, I'm trying 10. Replace x by 10. I'll put it down here, of course, it's positive. 10 subtract 2, +8. 10 plus 2, +12. Oh, that's nice, because all those are positive. Is that true? Which I can use. So this says you may also have, as part of your answer, this. Did we check it correctly? We're careful. Now, what does the answer look like? Well, you got to name the shade regions. Final answer, someplace right next to the problem, right here. From -2 up to 0, looks like this. That's part of the answer. And where else did I shade? To the right of what? 2. Now, since I have another part of the answer, your textbook likes to show something that looks like a U for union. Show there's another piece. Union that with another piece. And the other piece is down here, written as 2 through infinity. And there's your answer with sign analysis applied to that problem. Making sense? So far, so good? Beautiful. I'm about to finish this up for what we're going to do right here. Oh my goodness. Here goes. Okay, letter E. And I may stop, guys, with these types. I'll do something else here. X squared plus 2x plus 4 is greater than 0. Now I debated whether to bring this one in. I'm going to use this for my last example of these types. And And I'm moving into something entirely different here as a topic to close down tonight. Look at it. You saw me do this one. And I factored in red. You saw me do this one. We factored in red. This one, to save me a little time, we're not factored. This is going to factor. Anyone have an idea? Is it going to factor, guys? X squared plus 2x plus 4, that's not going to factor. So my goodness, Professor, wait, so you said you can't get to here? You can't get to here? Well, how are you going to do the problem, Professor? And yet they want an answer. USC says solve this. And you're sitting there, don't let them know you came from SMC. If you can't solve that, they want an answer. They're saying you should be able to see something here. It's a little strange, though. That's why I saved it for my last example. It will be a little strange, but no factoring. That's why I brought it in as my last example. Let me get some input first, and I'll show you what I might suggest. Go for it. He says, Professor, it's not going to factor. Could I use that completion of the square process? Watch what's going to happen. Wow. I'm going to try completion of the square. That means let's move that 4 over, out of the way. Oh, I love what he said. By the way, my leading coefficient's a 1, and that was a restriction. I can't complete the square unless it's a 1. Thank goodness it is a 1. And now I'm ready to add those blanks like we were doing before the break. To complete the square, he wants me to do this. This is nice. Nice. Wait till you see what's going to happen. I'm trying to think which semester back in the past did a student tell me what you told me to do. I can't think when. Students usually get baffled by this one. This example, they go, oh, I don't know how to do this. I've got to complete the square. Guys, what will it take on that blank to complete the square? Now you divide this by 2, or take half of this, or divide it by 2, you get a 1. Then square it, you still get a 1. So that's pretty easy. If I place it here, you gotta place it here. Keep it balanced. Therefore, the left-hand side should be, that's why they call it completion of the square, it should be a nice perfect square now. Can anyone tell me what the left-hand side should look like as a nice perfect square? That's why they call it complete the square. What is it? X plus 1? Quantity squared. That's what I want. That's completion square. The other side gives me something, oh, it gives me this. True? This is my last example. I've got some clever students in class. And I know my students, I know how I was in class. I'd probably sit in the back as a student. I was quiet. I wasn't one of those that would shout the answers and raise my hand and all that. I was very quiet. I watched everything being done. And when I took my test, I got 100%. I got 100% on the test. I was very quiet. But then my roommate was, hey, I know the answer in class, which I appreciate because he asked things maybe I should have been asking. I was just very quiet. Now, before we close this down, don't do this right now. This is what we're looking for. If it had said this, don't lose this in your notes. If it had been that and not an inequality, what would you have to say immediately? Now, don't disappoint me here at the end.
You can't square root a negative.
Yeah, you say, well, Professor, I thought you were supposed to do a square root on each side. I think that's what I was doing before the break, wasn't it? Do a square root, and here you'd be what, attempting to take the square root of a negative? You say, Professor, stop. You can't do it. You've done all that work for nothing. There's no solution. But it was not equals. It was that. You're going to be shocked what the answer is. I will tell you ahead of time, there is an answer this time. I'm not going to do a square root. I'm going to use a little common sense on this. There's an answer. Now, can someone tell me what is going on here? Just looking at it. You've got to use a little common sense. And tell me, Professor, it means this. Let's see if I show of hands well enough. Let's see if the student can sort of translate what this, read a little math here, read it to me. What does it mean? Okay, let's see. Go for it.
The left side can't be negative number, and
Wait. The left-hand side, x cannot be a negative number? Or the entire left-hand side?
entire.
So are you telling me the entire left-hand side, no matter what I replace x by, when I calculate it, it's got to be either a positive or it could be a zero?
Yeah.
Is that true? It's got to be a positive. If you square something, it gets a positive. Is that true? And in fact, also if I replace x by -1, you can also get a 0. Okay, so that left-hand side is guaranteed to be either a 0 or a positive answer. Now what do they want? They want you to look at the left-hand side and say, well, if it's a 0 or a positive answer, are all those numbers greater than -3? Oh my goodness. Oh my goodness, Ramsey. Just looking at it. Now, before I see some looks on faces, just randomly, suppose I choose a number like 10. Just random. I put 10 in. 10 plus 1 is 11. 11 squared is 121. Is 121 greater than a -3? I don't care what number you throw at me. If I put it in, I chose 10. I don't care. If it's a negative number, I'm going to try -10. Just a random. A -10 plus 1 is a -9. But you got to square it. What's a -9 squared? 81. Is 81 greater than -3? Can anyone give me a number to replace x by and then square it where it would not be true? No. What's the answer? Got you on this one? That's why I love teaching. Got you on this one. What's my final answer on this last example? Everything works. All real numbers, they call it. No imaginaries, no eyes. Everything. I don't care what you replace x by. You do that business of there, it's going to be a true statement. All real numbers. Some textbooks and some professors will use this symbol. It's like a little strange R, script R, for real numbers. I prefer, since we're talking about interval notation, say it like this. Negative infinity through positive infinity. Everything works. It shows the entire number line works. Oh, by the way, one number I did not test, I tested 10 and I think -10. Suppose you put a -1 in there for x. -1 plus 1 is 0, isn't it? Square it, still 0. Is 0 greater than -3? It even works. Put a square root 2 in there. It'll work. Put pi in there. It'll work. So this one has every real number is your answer. This is one where all numbers work. Okay? It all works there. Okay, guys, I'm going to stop for that. Watch my time here. Now, I think we've done a good job tonight. Now, I set you up for the quiz on Wednesday. That's why I did this. Again, please, your quiz is going to be a short quiz, 10 points. But I'm going to do the quiz at the end of class. So I noticed there's not another class coming in after we leave. And so in case exam day or quiz day, some students may say, Professor, you lectured so long, you didn't give us enough time for the quiz. The quiz is probably 30 minutes on Wednesday. We can stay a little longer after class. Class ends at, 7:25? And I could say, well, come on, guys, you can stay another 5 or 10 minutes if you want to, or 15 minutes to finish up the exam. Therefore, no professor's going to come in. There's no class after we leave, which is nice. So that's why I do it at the end to give you more time to finish up the exam, finish up the quiz. Okay? Guys, any concerns here? Yeah. I don't think so, right? Now, let's do this. Let's see if I'm ready for it. Oh, yes, I am ready for it. Guys, I will probably just get a start on, let me see what this is. Yeah. This handout, we'll probably just have time to do one side here. This will bring back fond memories. Should bring back fond memories. I think it's much easier. This is the beginning of chapter 1, by the way. The review part's done. I think this is going to be much easier than what we've done here. Where do you see this? So I may be able to get one side of this done tonight, which I hope so, in the time I have remaining here. Mr. Park, can you do this for me?